Hi everyone, welcome back to Introduction to Artificial Intelligence and Machine Learning. In the previous session, we gave an overview and introduction on supervised learning and regression models, different algorithms, and how to evaluate a regression model. In this session, we will focus on unsupervised learning and its algorithms. As the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training dataset. Instead, the model itself finds the hidden patterns and insights from the given data. It can be compared to learning which takes place in the human brain while learning new things. Therefore, unsupervised learning uses unlabeled dataset to train machine learning model. Unsupervised learning cannot be directly applied to a regression or classification problem because unlike supervised learning, we have the input data, but we don't have the corresponding output data. The goal of unsupervised learning is to find the underlying structure of datasets, group that data according to similarities, and represent the dataset in a compressed format. Suppose the unsupervised learning algorithm is given an input dataset containing images of different types of cats and dogs. Here, we have taken an unlabeled input data, which means it is not categorized and corresponding output are also not given. Now, this unlabeled input data is fed to the machine learning model in order to train it. Firstly, it will interpret the raw data and find the hidden patterns from the data. And then it will apply suitable algorithms such as k-means clustering, decision trees, etc. Once it applies the suitable algorithm, the algorithm will divide the data object into groups according to the similarities and difference between the object, such as different shapes or different colors. The unsupervised learning algorithm can be further categorized into two types of problems. Here we have clustering and association. First, we talk about clustering. Clustering is a method of grouping the object into clusters, such that object with most similarities remains into the same group and has less or no similarity with the object in another group. Cluster analysis finds the commonalities between the data object and characterize them as per the presence and absence of those commonalities. An association rule is an unsupervised learning method, which is used for finding the relationship between variables in a large database. It determines the set of items that occur together in the dataset. Association rule makes marketing strategy more effective, such as people who buy item X, suppose it is a bread, also tend to purchase item Y, such as butter or jam. A typical example of association rule is market basket analysis. Same as supervised learning for regression and classification, there are also various types of unsupervised learning algorithms, such as k-means clustering, k-nearest neighbors, hierarchical clusterings, anomaly detection, principal component analysis, and singular value decomposition. In the following session, we are going to focus on a few important unsupervised learning algorithms and give you more details. K-means clustering is an unsupervised learning algorithm that is used to solve the clustering problems in machine learning and data science. In this session, we will learn what is k-means clustering algorithm and how the algorithm works. K-means clustering is an algorithm that groups the unlabeled dataset into different clusters. Here, K defines the number of predefined clusters that need to be created in the process. As if K equals 2, there will be 2 clusters. And for K equals 3, there will be 3 clusters, and so on. It is an iterative algorithm that divides the unlabeled datasets into K different clusters in such a way that each dataset belongs only one group that has similar properties. K-means clustering allows us to cluster the data into different groups, and it is a convenient way to discover the categories of groups in the unlabeled dataset on its own without the need for any supervised training. It is also a centroid-based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data points and their corresponding clusters. K-means clustering algorithm takes the unlabeled dataset as inputs, divides the dataset into K number of clusters, and repeats the process until it does not find the best clusters. The value of K should be predetermined in this algorithm. The algorithm mainly performs 2 tasks. First task is to determine the best value for K center points or centroids by an iterative process, and to assign each data point to its closest K center. Those center points, which are near to the particular K center, create a cluster. Hence, each cluster has data point with some commonalities, and it is away from other clusters. The diagram explains the working of K-means clustering algorithms. Step 1 is to select the number K to decide the number of clusters. Then, the model will randomly select K points or centroids and assign each data point to their closest centroids, which will form the predefined K clusters. After that, the model will calculate the variance and place a new centroid for each cluster. Subsequently, the model will repeat the process to assign data points and relocate the centroid until there is no more changes. Next, we will talk about how to choose a proper value of K and how to evaluate the performance of K-means clusterings. The performance of K-means clustering algorithm depends upon highly efficient clusters that it forms. But choosing the optimal number of clusters is a big task. There are some different ways to find the optimal number of clusters. But here, we are discussing the most appropriate method to find the number of clusters and value of K. The elbow method is one of the most popular ways to find the optimal number of clusters. This method uses the concept of WCSS values. WCSS stands for within cluster sum of squares, which defines the total distance within a cluster. To measure the distance between a data point and a centroid, we can use any method such as Euclidean distance or Manhattan distance. The elbow method will execute the K-means clusterings on a given dataset for different K values. For example, it can range from 1 to 10. For each value of k, it calculates the WCSS value. Then it will plot a curve between a calculated WCSS value and the number of clusters k. The sharp point of band is considered as the best value of k, because WCSS will not drop significantly anymore, even for a larger k value. Since the graph shows the sharp band, which looks like an elbow, hence it is known as the elbow method. The graph for the elbow method looks like this image. Initially, when k equals 1, the total variation is as large as 8,000. With increasing number of clusters, WCSS will drop. But of course, we don't want to have too many clusters, because we need to make sure each cluster is distinct from the others. Let's discuss the benefit and weaknesses of k-means clustering. First of all, k-means algorithm is relatively efficient and fast, and is very useful for undirected knowledge discovery. K-means has widespread application in a lot of fields, ranging from unsupervised learning of neural networks, pattern recognition, classification analysis, and image processing, machine vision, and many others. However, there are also limitations for k-means clustering. The number of cluster k must be determined beforehand. Its disadvantage is that it doesn't yield the same result with each run. Even the resulting cluster depends on the initial random assignments. Secondly, we never know the real cluster using the same data, because if it is inputted in a different order, it may produce different clusters if the number of data are not so many. Lastly, k-means clustering is very sensitive to initial conditions. Different initial conditions may produce different results of clusters. The algorithm may be tracked in the local minima. Let's move on and talk about another application of unsupervised learning algorithm, principal component analysis. Principal component analysis is also an unsupervised learning algorithm that is used for the dimensionality reduction in machine learning. It is a statistical process that converts the observation of correlated features into a set of linearly uncorrelated features with the help of orthogonal transformation. These new transform features are called the principal components. It is one of the popular tools that is used for exploratory data analysis and predictive modeling. It is a technique to draw strong patterns from a given dataset by reducing the variance. Principal component analysis generally tries to find the lower dimensional surface to project the high dimensional data. Principal component analysis works by considering the variance of each attribute because the high attribute shows the good splits between the classes, and hence it reduces the dimensionalities. Some real-world applications of principal component analysis are image processing, movie recommendation system, optimize the power allocation in various communication channels. It is a feature extraction technique, so it contains the important variables and drops the least important variables. As mentioned above, the transformed new features or the output of principal component analysis are called principal components. The number of these principal components are either equal to or less than the original feature present in the dataset. Some properties of these principal components are as below. Firstly, the principal component must be the linear combination of the original features. And these components are orthogonal. That is, the correlation between a pair of variables is 0. Finally, the importance of each component decreases when going to 1 to n. It means principal component 1 has the most importance, and principal component n will have the least importance. Next, we are going to talk about anomaly detection. Anomaly detection is a process of finding those rare items, data points, events, or observations that make suspicious by being different from the rest of data points or observations. Anomaly detection is also known as outlier detection. Generally, anomalous data is related to some kind of problems such as bank fraud, medical problems, malfunctioning equipment, etc. Finding an anomaly is the ability to define what is normal. For example, in this image, the yellow vehicle is an anomaly among all red vehicles. Anomaly detection techniques are broadly categorized into two types: supervised anomaly detections and unsupervised anomaly detection. For supervised anomaly detection model, it needs the label training data, which contain both the normal and anomalous data for creating a predictive model. Some of the common supervised methods are neural networks, support vector machine, k-nearest neighbor, Bayesium networks, decision trees. K-nearest neighbor is one of the most popular non-parametric techniques, which finds the approximate distance between different points on the input vector. This is probably one of the best anomaly detection methods. Another popular model is called Bayesium Network, which is used for anomaly detection when combined with statistical schemes. This model encodes a probabilistic relationship among variable interest. Supervised anomaly detection techniques have different advantages, such as the capabilities of encoding interdependencies between variables and of predicting events. It also provides the ability to incorporate both prior knowledge and data. For unsupervised anomaly detection, it doesn't require label training data. These techniques are based on two assumptions, which are most of the data are from normal traffic, and only a small amount of data is abnormal. Malicious traffic is statistically different from normal traffic. On the basis of these assumptions, data clusters of similar data points that occur frequently are assumed to be normal traffic, and those data groups that are infrequent are considered abnormal or malicious. Anomaly detection can effectively help in catching the frauds, discovering strange activities in large and complex big data sets. This can prove to be useful in areas such as banking security, natural sciences, medicine, and marketing, which are prone to malicious activities. With machine learning, an organization can intensify search and increase the effectiveness of its digital business initiatives. Finally, let's try to summarize the pros and cons of using unsupervised learning to solve data problems. Unsupervised learning is used for more complex tasks such as compared to supervised learning, because in unsupervised learning, we don't have any label input data. Therefore, unsupervised learning is preferable as it is easy to get unlabeled data in comparison to labeled data. However, there is also disadvantage associated with unsupervised learning. Firstly, Unsupervised learning is intrinsically more difficult than supervised learning, as it doesn't have any corresponding outputs. Hence, it is difficult to evaluate the model performance. Moreover, the result of the unsupervised learning algorithm might be less accurate as input data is not labeled, and the algorithm don't know the exact output in advance. Well, here comes to the end of topic 1. In this topic, we talk about the concept of artificial intelligence and machine learning. We gave an overview of the general machine learning workflow and different types of machine learning algorithms. Finally, we gave a detailed introduction on the two major machine learning algorithms, supervised learning and unsupervised learning, the pros and cons of both algorithms, and their use cases in the real-world environments. We hope you enjoy the lesson. See you in the next topic.